Hello everyone, welcome to today's webinar, VMware Cloud on AWS, Technical Deep Dive. Before we get started, I have a few housekeeping items. On the right side of your screen, you'll see a Q&A window. Please use this to submit your questions for our presenter and moderators at any time. We'll address them as they come in. At the conclusion of today's presentation, there will be several poll questions during live Q&A. Please take a quick minute to provide us with your feedback when you see these poll questions appear on your screen. We are recording today's session, and in the next few days we will send you a follow-up email with links to the deck and the recording. Again, welcome to today's webinar, VMware Cloud on AWS, a technical deep dive. Our presenters today are Andy Reedy, Wen Yu, and Arthi Raju. Andy, welcome. The floor is now yours.
Great, thanks. Hello everyone, thanks for joining today's webinar. My name is Andy Reedy, and I'm going to start off the presentation today by walking through a brief introduction to VMware Cloud and AWS. We'll start diving in deeper as we go along into how the various components of the service work, how you can actually leverage the service to solve problems that you may be facing in your environment today. I'll then hand it over to Wen, and Wen is going to walk through a demo of the environment so you can get a chance to see it actually used in some real-life use cases. And then at the conclusion, we'll bring in Arthi to answer some questions that you may have. So please use the Q&A feature, and we'll address those at the conclusion of today's webinar. So to get started, I want to start off with defining a couple of terms. So the first one is software-defined data center. So from a software-defined data center perspective, there's really three main components. You have compute virtualization using ESXi, you have storage virtualization using vSAN, and then you have network and security virtualization using NSX. All of these components, VMware components, comprise together, virtualize all of the features and functionality that you would have in a physical data center. So from a VMware Cloud and AWS perspective, this is an on-demand service that actually delivers software-defined data center as a cloud service. So you can click a button in a console or make an API call, and you can deploy a complete environment running VMware Cloud and AWS and all of these software-defined data center components that are completely configured and ready to use out of the box. VMware actually maintains and manages these components for you, so they will take care of patching and updating and upgrading all of these components. So whenever you go to provision a new host into a cluster, you do not have to actually configure that host and install ESXi and join it to your cluster. It is pre-configured, pre-joined to your cluster and ready to go. The same goes for vSAN and NSX. So all of these components are completely configured, maintained, and managed by VMware, and they're kept up to date running the latest software. You also get the advantage of dynamic capacity. So being that this is running in an AWS environment, you have the ability to add and remove hosts dynamically. So with the click of a button, you can add a new host to a cluster, or you can remove a host from a cluster. You can scale the entire cluster to meet the needs of your demand. The setup actually uses vSAN for storage. We'll dive into that a little bit further, as well as the NSX virtualization capacity. We'll dive into that as well. Okay, so let's go through each one of the components of the software-defined data center and get a sense of how each one of these components are used and how they work together to deliver this service. So from a compute perspective, VMware Cloud and AWS is deployed directly on bare metal inside of the AWS EC2 environment. So this is not nested virtualization or any type of BERT-on-BERT scenario. This is the ESXi hypervisor running directly on AWS bare metal. The hardware that we're using to deliver this service is equivalent to an i3-16XL. So if you're familiar with that instance type and family, each one of these hosts will have 36 cores or 72 vCPUs, 512 gigabits of memory, 15 terabits of NVMe all-flash storage, and it uses the enhanced network adapter for 25 gigabit of network capacity per host. There are some caveats on the storage. We'll talk about that in just a moment. While the raw capacity numbers for each host are at 15 terabits, the actual usable is going to be slightly different because of some caching and capacity split that is done there. We'll talk about that as we get into vSAN. From an ESXi perspective, this is the same ESXi that you would run on premises. This is not anything that's special or drastically different than what you would run on premises. This is the ESXi hypervisor that you would use in an on-premises environment. You're able to deploy clusters in the range of a minimum of 4 hosts, up to a maximum of 32 hosts in the cluster, and you are able to deploy multiple clusters in in an environment. This cluster and all of the components are maintained by VMware, as we mentioned before. And as this is a supported cloud service, there are some restrictions from a permission perspective. So you're not going to be able to SSH directly into an ESXi host, and you're not going to be able to install VIBs or any kind of third-party plugins directly on the hypervisors themselves. From a storage perspective, VMware is leveraging vSAN to essentially aggregate the local storage of each one of these hosts. So as opposed to kind of a traditional AWS EC2 environment where you would attach an EBS volume and you would run your data there, VMware Cloud and AWS actually leverages the high-performance all-flash NVMe capacity of each one of these hosts, and then leverages vSAN to aggregate that capacity together to create a distributed data store. So there is no external EBS or EFS that can be used from a data store perspective. However, you can use EFS from a workload. So from a VM running inside of VMware Cloud and AWS, you can attach EFS there. But you're not able to use external EBS volumes or to attach external EFS volumes to be used as a data store. You are able to create individual VM storage policies to control the parity bits that are set for each VM, so you can set individual failure to tolerate settings from a VM perspective. From a network and security perspective, this is using VMware's NSX. So NSX is going to create logical networks. So this is not running directly inside of an AWS subnet, so your VMs are not attached to an AWS subnet. Your VMs are attached to an overlay network in the form of an NSX logical network. So this allows you to create logical layer 2 networks inside of VMware's NSX platform. And those logical networks are connected into compute and management gateways. So there's two components here. The compute gateway is essentially a virtual machine that's running that provides the gateway services for all of your compute workloads. So you can have multiple NSX, or you can have multiple logical switches that are all connected up into a compute gateway, and that's where your compute workloads would run. And then a management gateway is where things like vCenter, the NSX control cluster, NSX manager, all of those things are going to be running inside of a management logical network, which connect up through a management gateway. The gateways themselves act similar to an IGW, if you're familiar with that, the internet gateway on an AWS side, except they do some additional things. So they provide gateway services for all of the logical networks, but they also act as a IPsec termination point for IPsec VPN tunnels. They perform NAT. They'll do your north-south firewalling, so all of the ingress and egress traffic out to the internet will be firewalled by the compute gateway and the management gateway components. And then vSphere. So this is something that is a huge advantage for VMware Cloud and AWS, is that you're not having to learn a new platform. You're not having to manage the VMware Cloud and AWS environment in any way. vSphere is vSphere. This is the same vCenter interface that you're accustomed to using on premises. It is managed by VMware, so there are some differences here. It's its own single sign-on domain, and then you are delegated rights to an account that allows you to actually manage your workload. So you do not have full administrative rights into this environment. You have a cloud admin account, and this cloud admin account is delegated permission that allows you to manage your workloads appropriately. VMware's introduced a new feature called hybrid linked mode, and the hybrid linked mode allows you to connect the single sign-on domain that is running inside of VMware Cloud on AWS into your on-premises environments. So the VMware Cloud and AWS software-defined data center will show up just as another data center in your on-prem environments without having to be connected back into that single sign-on domain. So looking at the big picture, there's really three pillars, and you'll see this as we go through the session today. There's kind of three pillars to talk about. There's the customer data center, your on-prem environments that you have today, the VMware Cloud and AWS software-defined data center depicted there in the middle, which is running vSphere, vSAN, and NSX, and then the AWS environment. So when you set up VMware Cloud on AWS, you'll configure and connect it to a AWS account that you, the customer, own, and that account is used to actually run native AWS services. So this allows you to connect into things like Amazon's RDS or Amazon's Redshift, or even EC2 instances that are running in your own account. You can have high bandwidth, low latency access through a private connection into your account in order to have your VMware Cloud and AWS workloads and VMs running inside of your SDDC be able to connect back into these native AWS services. And this is huge. This gives you the ability to extend and expand your applications to take advantage of all of these services without having to actually re-platform or convert your workloads to run natively in AWS. And likewise, you have the hybrid linked mode that we talked about briefly a moment ago, to where you can actually have a single pane of glass to manage your workloads both in your on-prem environment and in your VMware Cloud and AWS environment. So you're not having to toggle between multiple interfaces. You can essentially use that same vCenter interface that you're accustomed to today to actually manage your on-prem workloads as well as your VMware Cloud and AWS workloads. So this is actually delivered in a slightly different way than what you may be accustomed to with native AWS services. So there's two different accounts involved with VMware Cloud and AWS. So the first is when you sign up for this service, VMware is actually going to create a brand new AWS account. And this is an AWS account that VMware owns and operates. They pay for this account. It is completely their account, and you will have no visibility to this. They use this account to actually create and run all of the SDDC resources that are needed to run your VMware Cloud and AWS environment. So all the ESXi hosts, the NSX Manager, the NSX Control Cluster, all of the networks and everything exists inside of this account. There's a second account, which is your AWS customer-owned account. So this is an account that you own and you operate. This is not paid for by VMware, or it's not linked to any AWS VMware account. This is your customer AWS account. So this is paid for by you, and we establish private connectivity between these two accounts. So your VMware Cloud and AWS account is, you will pay a bill to VMware for all of the services that you consume inside of VMware Cloud and AWS. And your AWS account, which is owned and operated by you, the customer, where you would run all of your native AWS services, you would have a bill from AWS for that perspective. So two separate accounts. You interface with VMware Cloud and AWS through vCenter and through the VMware Cloud and AWS console, but you do not have visibility into the underlying AWS account, which is actually running the service. And then your customer-owned AWS account, where you would actually have all of your native AWS services. If you wanted to use things like RDS or DynamoDB or Amazon's Redshift, you would do all of those things inside of your AWS customer-owned account. And then you would be able to connect those two together through this connectivity that we'll establish between these two things. Okay, so getting started. So if you want to sign up for VMware Cloud on AWS, the first thing you'll do is go to vmc.vmware.com. And this is the VMware Cloud on AWS console. This is where you will manage a lot of the higher level functionality and the account level setup. So VMware Cloud on AWS, you'll log in using your my.vmware.com credentials. And you can create organizations, and VMware has an identity and access management system that is similar to what we have in AWS, but it's in through this separate console. This is not AWS IAM, this is not AWS organizations. This is VMware Cloud on AWS. You can create organizations there and put all of your resources inside of an org. You can create users there, give those users access and permissions to different orgs, and that's where you will actually create your software-defined data center. When you go to create your software-defined data center, you'll have to provide a few different things. One, you give your SDDC a name. You define the number of hosts that you would like in that environment, and you choose which region you want the SDDC to run in. You'll also go about connecting this to an AWS account, and you'll go through a process of actually connecting your SDDC into your native AWS account. So once you have an SDDC provisioned, you essentially have two different places you can go to. One is the vmc.vmware.com console. So this is where you can do things like add and remove hosts if you want to grow or shrink your cluster. If you want to create new users for your organization and assign those roles, whether it be an admin or a member user. You can do firewall configuration. So VMware's actually created a really intuitive interface that allows you to manage basic network configuration. So you can create new logical switches. As we talked about before, we have these logical networks. So you start off with the default logical network for your compute resources, but you don't have to put everything in one. You can create multiple logical networks for all of your compute workloads, similar to how you would do on-prem with either VLANs or logical networks if you're running NSX on-prem. You can do all of your elastic IP and NAT configuration through this interface, and your VPN connectivity. So it's a simplified interface, very intuitive to use for managing basic network configuration, user role administration into your SDDC, and those types of things can all be done through the vmc.vmware.com console. Likewise, to actually manage your workloads, you would just log into vCenter just as you would on-prem today. So the vSphere HTML5 web client is available. You would log into that using your cloud admin credentials. And here you can also do logical network configuration. You can manage your virtual machine workloads, your VM storage policies. All of those things can be done in through the HTML5 web client. So two different entry points, your vmc.vmware.com environment and your HTML5 web client for vSphere. So as we mentioned, this is delivered as a service. So the access model is slightly different. So AWS is going to manage all of the physical resources. You as a customer are not going to be responsible for having to deal with physical power cooling, replacing failed components and hardware, adding new hardware. AWS is going to take care of managing all of the physical resources in the environment. VMware is going to take care of managing the hypervisor and all of the virtualization components. So ESXi, vSAN, NSX, they will take care of installing, configuring, updating, patching, all of those things inside of the virtual environment, VMware takes care of. You as the customer get to focus on actually managing the VMs and running your workloads. So you'll take care of deploying and configuring the VMs, installing the operating systems, configuring your applications, those types of things, but you no longer have to worry about the physical components, and you no longer have to worry about configuring and managing the virtual infrastructure itself. So access via vCenter, as we mentioned, is through delegated permission model, so you do not have administrative access into this. You'll have a cloud admin account which has delegated rights. As this is a supported service, you will need to be aware of a few things. One is you do not have root access into this. You will not be able to actually configure or manage the underlying VDSs, and you will have no direct access into like NSX Manager, the NSX Control Cluster, those types of things. Your level of configuration for NSX and interfacing with this is through the VMware Cloud and AWS console and through the APIs that it provides. But you will not have direct access into NSX and those types of things to be able to manage this directly underneath. Again, it's delivered as a service, and so think of it as a service as opposed to a co-located vSphere environment. It's not a co-located vSphere environment. It is a cloud service that is delivering a software-defined data center. Okay, so some common scenarios and use cases. So we've been talking to customers about VMware Cloud and AWS for a little over a year now, and there's some common scenarios and use cases that people are interested in and are starting to leverage this service for. So the first one that we hear a lot about is customers who are looking to maintain and expand. So these are customers who have existing environments. They've invested a lot of capital. They've built up these data centers. Maybe they're depreciating them over long periods of time. But they're not necessarily looking to continue to invest in building physical data centers or to expanding the data centers that they have. So in this case, they can keep the existing data centers they have, but all of their new workloads, all of their future expansion, whether it's in new geographies, new regions, or even just capacity for their existing environments, they're going to basically freeze their existing infrastructure and do all future expansion in VMware Cloud and AWS. So this is very much the hybrid use case. You have your on-prem environments which will stay the same, and you will start building all new capacity in VMware Cloud, and you will connect those together, leveraging the various connectivity options that we have available, and run those in a true hybrid use case. This is also fairly popular for disaster recovery. So in a lot of cases, people will take their old hardware, their old environments, or they will invest in capital to build a smaller DR environment. In this case, VMware Cloud and AWS can be leveraged to dynamically spin up capacity on demand, which is great for a DR use case. The second scenario we hear a lot about is consolidating and migrating. These are customers who are actually looking to reduce the number of data centers that they have. Maybe they have data centers that are old, in need of a refresh or in need of a lot of maintenance, or customers who are looking to get out of the data center business altogether. So in this case, customers can either shut down their data centers and easily migrate their workloads into VMware Cloud and AWS, or reduce the number of data centers that they have and move into VMware Cloud and AWS. The idea here is that they don't have to go through a transformation process. They can do this migration literally with a right-click on the console, a right-click on the VM and migrate, It's a very seamless process to be able to move. No transformation, no replatforming, nothing like that. You're moving from a VMware environment into a VMware environment, so it's a very seamless transition to be able to consolidate your existing environments and migrate those into VMware Cloud. The third scenario we hear a lot about is just flexibility. So a few things we hear in this case are cyclical workloads. So if you're in any type of e-commerce or retail type environment, the fourth quarter may be a large increase in demand on your platform. So being able to dynamically scale up your platform to meet that demand, and then turn it down whenever you no longer need it. Be able to grow and shrink your capacity based on what your demand may be. Second in this area is in a temporary capacity. So if you have projects, maybe there's a proof of concept you want to build, or you have a temporary development effort that needs a new environment. And in the past, you may have had to invest hundreds of thousands of dollars in capital to be able to spin up an environment temporarily, and only to have the project not continue forward or to change direction. But you've already invested in this capacity, and you're no longer able to leverage it. So with VMware Cloud on AWS, you can literally go into the console, deploy a new software-defined data center. You can keep it for a day, a week, a month, a year, whatever time frame you need. You can scale that environment up or down based on your workload needs, and then turn that cluster down or scale that capacity down, based on what you actually need. This is also a good use case for bursting. Again, if you have cyclical demand, maybe scale it up for the fourth quarter whenever your demand is high, or whatever your seasonality may be, and then scale it back down when it's no longer needed. So what do we hear from customers as far as what they want in a hybrid environment? So we hear a lot of talk about hybrid use cases and people wanting to run in a hybrid cloud architecture. What does that actually mean? What do we hear that people want? So it really boils down into a few different things. We hear from customers that they want to be able to run workloads on premises. They don't want to be forced to run everything into the cloud environment. They don't want to be forced to run everything on premises. They want to be able to run on-prem and in the cloud. But they don't want to necessarily have to make this a binary decision. They don't want to be all in one or all in the other, or be forced into using one platform over the other. They would like to be able to do both seamlessly. We hear that they want tight integration between these two platforms, or to have the differences between running on-prem and in the cloud be as minute as possible, not having to maintain massive differences in management between running workloads on-prem and running workloads in the cloud. And we hear a lot that they want to be able to do this without buying new hardware. We rarely talk to customers who say, hey, I would like to be able to run into this hybrid environment, but I want to have to spend a few $100,000 in order to do this, and then I'm continuing to invest further capital in my on-premises data centers. We hear from customers that they want to be able to run on-prem, they want to be able to run in the cloud, they want to be able to move seamlessly between these two environments and have really tight integration without having to buy new hardware, without having to invest more capital. So if that's what we're hearing people want, what are the challenges? What are the things that really give people pause or make them have struggles with running in a hybrid environment? And they can really be broken down into a few different categories. So the first one is multiple machine formats. If you have a workload running on-prem and you want to move that into the cloud today, you have to go through a transformation effort. You're having to re-platform. You're either converting from a vSphere VM running on-prem into an Amazon machine image in the cloud. But you can't just pick up and move that workload live while it's running. You have to actually shut it down, re-platform it, bring it up, and configure it in the new environment. And then you have the incongruent networks. So you have IP networks on-prem, you have IP networks in the cloud. You're having to actually change IP addresses or change your workload to run in a new address space whenever you move to the cloud. So then you have DNS changes, all of these things that kind of go along with having to re-IP a workload. That's something that's also not seamless when trying to move a workload between on-prem and in the cloud. And then you have the operational processes. So if your operations teams are like most, you have runbooks. And you have runbooks for just about everything, from provisioning a workload to deprovisioning a workload to scaling to responding to a failure. There's runbooks for all of these things. And having to have a runbook for responding or conducting an event in an on-prem vSphere environment and doing that same operation in a AWS EC2 or AWS Cloud environment, is different. So now you have different runbooks for different platforms. So there's inconsistencies in how you actually run these workloads in the two different platforms. And the fourth is skill set and tooling. So you have skills and tools necessary to actually run workloads in a vSphere environment on-prem. Whether you created automation scripts to be able to perform some of these common tasks on-prem, or you've purchased third-party software to actually assist in managing workloads in on-prem or in the cloud. Ultimately, you have scripts, you have tools, you have skills that your staff has learned, and having to keep up with those things, not just initially learn them, but actually keep up as these platforms each mature over time, that can be challenging. And lastly, there's monitoring and control. So if you've ever gone through an audit and you've had to go through and actually dig up all of the permissions that all of the accounts have and all the firewall rules and all of the things that exist in your on-prem environment, and then go through that same task in the cloud environment, these are two different platforms. They each have different ways of implementing controls, and so having to go through and essentially do that work in two different platforms is challenging. So VMware Cloud on AWS helps address these because you're running vSphere in both of the environments. You're running vSphere on-prem, you're running vSphere in VMware Cloud on AWS. So now you have a common platform that you can leverage, and you're not having to go through and deal with converting machines or replatforming VMs. You're not having to change networks. You have the connectivity ability that we'll talk about to be able to run layer 2 VPN, so you can actually stretch your networks from on-prem into the cloud. All of your tooling and your skill sets and your processes, runbooks, all of your processes are essentially the same. This is the same platform. You're not having to deal with two separate platforms here. So VMware Cloud on AWS really helps address a lot of these challenges. Let's talk about some connectivity options. So, with a hybrid environment, a big thing there is being able to actually connect your on-prem into VMware Cloud on AWS, as well as expand your applications to take advantage of many of the native AWS services. So first, to start off with, let's just talk about connecting your on-prem data centers into your VMware Cloud and AWS environment. So there's really three options here. So the first and easiest option to talk about is Ipsec Vpn. So this is an extremely common method that folks use to connect their environments. They can connect up an Ipsec VPN between their on-prem environment and their VMware Cloud and AWS SDDC. In addition, with VMware Cloud and AWS, there's a new option that's just come into technical preview to actually create an L2 VPN. So this is a layer 2 VPN using a bespoke NSX edge on-prem, so you do not have to run full NSX in your on-prem environment. You can leverage essentially a virtual appliance which gives you the L2 VPN capability, and then you can stretch layer 2 connectivity across that. One of the things you can also do is you can leverage Direct Connect to help enable live vMotion. So there's some caveats and nuances here. Direct Connect will not be available to provide connectivity into the overlay logical networks, but it will provide connectivity into the underlying VM kernel ports to enable live vMotion. So the options you have are L2 VPN or Ipsec, and then you can enhance your L2 VPN capability to enable live vMotion by using Direct Connect. And then connecting your on-prem data centers into your customer-owned AWS accounts. This is pretty much the same connectivity you have today. So you have the option of using Ipsec VPN to connect those two together, but you can also use Direct Connect. So Direct Connect allows you to connect your on-premises networks into the AWS VPC subnets that you have in that environment today. And then we have a new connectivity option for connecting your VMware Cloud and AWS software-defined data center into your customer-owned AWS account. So as we mentioned, one of the setup pieces for VMware Cloud and AWS is that you define an AWS account that you want to connect your SDDC to. So when you connect these two together, we'll actually have ENIs in your AWS account, which are connected back to the SDDC. You can think of this very similar to how like RDS works or EFS works. You don't actually see the RDS instances running inside of your AWS account, but you have ENIs that show up that facilitate connectivity into your RDS instance. So it's very much a similar setup here. You have ENIs that are in your AWS account that'll be sitting in AWS VPC subnets, And those ENIs will provide connectivity back into your VMware Cloud and AWS software-defined data center. Likewise, if you want to connect to AWS accounts that are in other regions, you have the ability to actually create VPN connectivities from that compute gateway that exists inside of your SDDC, that virtual appliance gateway that is the edge of your software-defined data center. You can connect a VPN connection from that VPC to an AWS account in another region. So running through a couple of hybrid examples real quick. So in this case, we have two customer data centers. We have customer data center number 1 on the top left, and customer data center number 2 on the top right. And then we have our VMware Cloud and AWS account in the middle, and we have two software-defined data centers, one for Team 1 and one for Team 2. So in this case, Team 1 is looking for live vMotion capability. They want to be able to actually expand networks and connect them between the two environments. They want to be able to seamlessly move workloads between their on-prem data center and their SDDC. So in this case, they could actually build a layer 2 VPN connection over the internet, or they could build that layer 2 VPN connection over a direct connect if they so chose to do so. But this would give them the ability to seamlessly migrate workloads between their on-prem environment and the VMware Cloud on AWS SDDC. So for team number 2, they do not necessarily care about being able to live migrate VMs. They're actually looking to consolidate this data center down and shut it down. So in this case, they just want to be able to move the workloads easily without having to go through a re-platforming effort. So they could actually just leverage an Ipsec Vpn connection between a standard firewall that they have in their on-prem environment and the CGW that's running inside of their SDDC. So this provides basic IP connectivity. They can then take those VMs, move them over into VMware Cloud and AWS, and then shut down that data center when it's no longer necessary. So we talked briefly about that ENI connectivity that went between the SDDC and the AWS account. I wanted to drill in on that and go a little deeper so you can have a sense of how that actually works. So your CGW and the SDDC there on the left is connected to a logical network. This logical network has 172.31.1.0/24 as its IP space. We have VMs running inside of that logical network. These VMs would like to be able to take advantage of things like Amazon's Redshift or being able to connect into other EC2 instances. So in this case, they would have a route to go over to the customer-owned AWS account, which you connected into your SDDC at the beginning. So the CGW has a connection through an ENI, or actually through a series of ENIs that are present in your AWS account. And this provides that connectivity over between the logical network on the left and those VPC subnets on the right. So in this case, I could connect from my 172.31.1.0/24. I could connect from that logical network over to my 10.1.1.0/24 or my 10.1.2.0/24 without any type of network address translation or anything like that. This is all private connectivity and would be very easily to connect without having to traverse the internet or set up VPN tunnels or anything like that. Okay, so let's put this all together and hopefully give you a good sense of how this will all fit together as far as running workloads across all the different environments. So let's say we have an e-commerce platform and we'd like to take our application and move it into the cloud. So in this case, we could easily take our web front end. We can make our web front end run on EC2 instances, and they could be set up behind application load balancers with auto scaling, use AWS WAF and CloudFront to front these resources, leverage things like Route 53. All this could be running natively inside of your AWS account. Within VMware Cloud and AWS, they could easily move their workloads into this environment. No platforming, no transformation effort. They could easily migrate their application servers to run inside of VMware Cloud and AWS. Their database servers could easily be moved into this environment. All their back office and billing systems, all those things could easily move into VMware Cloud and AWS without having to go through any type of re-platforming or additional effort there. And if they have, for example, like regional fulfillment centers, or there's some local workloads that have latency sensitivity, or there's geographic restrictions to where they have to run in a particular area, they can continue to run those workloads on-prem. They can leverage the connectivity we talked about, Ipsec Vpn or the L2 VPN, to connect those regional centers back into their VMware Cloud and AWS environment. And they could actually use their VMware Cloud and AWS environment to be burst capacity, to burst into the cloud for additional capacity whenever it's necessary. And likewise, since their database servers are running in VMware Cloud and AWS, they'd like to take advantage of additional capabilities like Amazon's machine learning or Amazon Redshift for data warehousing. They could expand and extend their applications to take advantage of these native AWS services because their applications are running in VMware Cloud and AWS. They have that high bandwidth, low latency access into those environments. So just to really kind of build the full value picture so you have a good understanding of where this all fits together from a value perspective. So we talked about this. AWS is going to manage the physical infrastructure. You're no longer going to have to deal with power and cooling, physical security, cage space, cross connects. All of those things are relevant in this environment. AWS will manage the physical infrastructure. VMware is going to take care of all the virtualization stack. So this is patching of ESXi, vCenter, NSX, all the provisioning and deprovisioning work. VMware will take care of all of this, so you no longer have to deal with those things. And then you have workload flexibility. So again, you can seamlessly move your workloads between your on-prem environment and VMware Cloud and AWS. You do not have to go through replatforming or transformation effort. You have the flexibility to run your workloads wherever you want and to move both to the cloud or back to on-prem as you see fit. And then you have elasticity. So you can scale your clusters up or down. So this is a massive difference between your on-prem environment where you're going through a lot of capital expenses and building out additional hardware, and then you're stuck with that hardware. There's no way to give it back when you're done. Ultimately, in this case, you can scale up or down based on business demand, and you don't have to worry about making large capital purchases. And speaking of large capital purchases, VMware Cloud on AWS, because it's delivered as a service, allows you to convert these large CapEx expenditures to variable expense based on use. So not only can you scale up or down to meet the demand of your business, but you only pay for what you need when you need it, and then you can give it back when you don't. And the ability to expand globally. So now you can deploy new data centers by going into a console and deploying a new SDDC. You're no longer having to deal with physical contracts, ordering equipment. If you've ever had to stand up a new data center in a different geographic area, those types of things can be very time-consuming and painful. In this case, you can click a button or make an API call and deploy a new data center in a different geographic region. And then there's the AWS services. So now you have the ability to expand your applications. Once you've moved them into the cloud environment, you have this high bandwidth, low latency access into all of these native AWS services. So if you want to take advantage of S3 object storage or RDS or DynamoDB or Amazon's Redshift for data warehousing, you can do all of these things, and you have this private, high bandwidth, low latency connectivity into all of these AWS services. So you can start expanding your applications to take advantage of the capabilities of the cloud. So with that, I want to hand things over to Win. Win is actually going to walk us through a demo and show us how this is used, practical uses for this service, and how it can be used to help you solve problems in a customer environment. Win?
Okay, so what we'll do here is highlight a customer use case that has been presented to us from a number of customers where the customers themselves, they have multi-tier application with a web server, front-end application, and database backend running on premises with VMware vSphere, and the customer would like to seamlessly migrate the entire application from on-premises into VMware Cloud and AWS solution without having to do any lifting and shifting, just a simple migration, followed by the ability to take full advantage of many of our native AWS services to provide layers of security protection for the applications once they have been migrated over. So to recap on what Andy mentioned in terms of the migration options, there are a couple of things to keep in mind here. The set of virtual machines, the web application servers, as well as the database backend, they can be seamlessly migrated, like Andy mentioned. Just right-click on the virtual machine vCenter server that's running on premises, and then select Migrate. Now, with the web contents themselves, customers do have choices. One of the ways they can do it is to leverage Amazon Elastic File System, EFS. So customers, if they have Direct Connect already connected into AWS, they could mount the Amazon EFS share directly onto the virtual machines that are hosting those web contents. What they can do in that case is to leverage a new capability that we just announced a week before we event, EFS file sync, to do high throughput copying of the web contents into EFS share without having to leverage the native copy command in Linux to accelerate the migration of the content. So with the contents being copied over from on-premises, the web contents, as well as the simple migration of the virtual machines now running on VMware Cloud and AWS, customers can then easily take advantage of many of our edge services, such as CloudFront, coupled with the AWS WAF, Web Application Firewall, to have the edge protection of their virtual machines that are not internet-facing anymore, with the ability to leverage the application load balancer to be the origin of the content distribution service. Okay, then the application load balancers will have the ability to have a target group load balancing with a group of IPs that are not necessarily native EC2 instance IPs. They could be virtual machines that are running on the ESXi host, and the load distribution of the web traffic coming in from CloudFront will be distributed across the virtual machines running on ESX. Now, in terms of end-to-end visibility of this infrastructure, we could leverage our Amazon S3 service to be the central point of data ingest for the access logs from CloudFront, the access logs from the application load balancer, the web server logs from the virtual machines, as well as the VPC flow logs for the VPC that's listed here. So in that case, we could then ingest the logs from a central location through Amazon Kinesis Firehose into Amazon Elasticsearch service, in which case the indices for these web application access logs can be created and visualized through Kibana in the user interface. What we'll show you in the demo is exactly all these services and how they tie in to work seamlessly in the VMware Cloud and AWS environment once the virtual machines have been migrated over from a premises seamlessly. So with that, let's step into the AWS console, starting with CloudFront, our content distribution service that's globally available with over 100 point of presence across the globe. So in this case, we could just deploy CloudFront to follow the best practice to use all edge locations. So what that means is customers don't necessarily have to do anything once they migrated the web content applications over to AWS. Instead, they could simply go global to serve contents to their users faster without having to even deploy, let's say, a VMware Cloud and AWS environment in another region. They could simply leverage CloudFront for those web contents serving out to the users. And I mentioned earlier, the WAF could be leveraged to intercept and monitor the traffic as they come in. We could highlight how that looks like for the end users in a little bit. So for now, I do want to highlight that with CloudFront, customers do have the ability to control the type of traffic they want to support and also control the traffic communication between CloudFront edge locations and the origin. We could restrict it to HTTPS traffic only. So that way, we could eliminate the malformed web packets before they even enter into the origin for the web application. So in here, as you can see, we have the flexibility to choose the SSL protocols that we support, as well as the type of origin protocol policy with HTTP only or HTTPS traffic only, all available as customer choices. Okay, so that's CloudFront in a nutshell. So now let's move on to the next service that we could tie in after a CloudFront distribution has been created, and that would be our DNS service, Route 53. So we do have the ability for customers to tie in their application fully qualified domain name with the CloudFront distribution very easily. So once the distribution has been created, then we can go into our hosted zone for our application DNS record. The one of interest is Demo 1, Application 2. So in here, what we do is we will create an alias record that will point to the CloudFront distribution. As you can see, we already have that set up in here, pointing to CloudFront as an alias. So if the customers are getting started, they could go into here and create an alias. And in here, we have choices for customers to choose as the resolution alias. It could be a CloudFront distribution. It could be a application load balancer or elastic load balancer if the customers are not going to take CloudFront as the service they want to consume yet. So those are all very flexible for the customers. Now let's move on to AWS WAF, which is a web application firewall that has protection for customers. So now since we have CloudFront enabled globally, then we will have to select the CloudFront global option here to show the application firewall that's integrated with CloudFront. So in here, once we click into it, we then have immediate visibility into the traffic that's being accessed from across the globe to the various POP locations. So in here, WAF has given customers the ability to create dynamic firewall rules to do pattern matching and guard against common web exploits such as SQL injection or cross-site scripting. So customers have the flexibility and ability to create whitelisting rules based on source IP address as a pattern matching as an example, or they could do blacklist rules to block specific IP address, or take specific action based on a pattern matching of the source IP or the custom URI or the web request header and even body. So all of those are available as options to create as a rule to do pattern matching. So what we can do is we can click into SQL injection as an example. So this is what we have as the filters to monitor the traffic, and if a pattern is detected, then we could easily change the firewall rules so we could take the necessary action to prevent access if necessary. Okay, just to give you some examples of the rule sets that we have. And let's now take a look at AWS Shield, which is a service that's available to customers. There are two levels here, two tiers. One is the basic and the other is advanced. So all AWS customers get the basic level free of charge to have DDoS monitoring as well as mitigation. So the basic level guards against common attacks, and this service will scale horizontally on behalf of the customer should there be any DDoS attacks. And customers, by virtue of using Route 53 CloudFront, the application load balancer, are entitled to subscribe to the advanced tier of Shield, which gives two key benefits to our customers. One of which is the ability to have access to our 24/7 DDoS response team, DRT, in which case we could help the customers create custom rules to be inserted into the pattern matching in what we have seen in the web traffic. And the second benefit is the ability to have build protection. So as I mentioned earlier, all of these resources will scale to absorb attacks to keep the customer's application available. Now, customers with advanced tier Shield will not be billed for these resources as they are being scaled to absorb the attacks, really giving customers the flexibility, the choice, and also the peace of mind by using these services. Now, we mentioned CloudFront, we mentioned Route 53, we mentioned WAF and Shield. Now let's talk about the application load balancer, which is the origin of CloudFront. I mentioned earlier, we have the ability to have the application load balancer configured with a target group that will direct requests to virtual machines running on SDDC. So to show you how simple that is, we simply go into the application load balancer that's pre-configured in the environment here. So in here, the forward rules is configured to forward into a specific target group here. So if we click into the target group, then we could belong to the logical network in which all the web servers are running. Okay, so outside the block here is the 172 IP address. The logical network with VMware SDDC environment is the 192, as you see here. So these are all entering as the web servers that are serving our web applications running in ESX happily. And we have the built-in monitoring of the health status for each and every one of these targets, despite they are not instances. Now we take that what it looks like from the user standpoint. Okay, so we custom create this site that is load balanced across a number of web servers running on ESXi host. So as you can see, this is displaying the private IP of each and every one of those web servers. So if we do refresh on the browser, then we should see the ALB in action, load balancing the requests across all web servers in the backend. Okay, so 13, 14, and 15 are all getting used simultaneously based on the traffic access. Okay. Now, there's one more thing that I want to highlight, which is available to customers with AWS, and that is a certificate manager. Okay, if customers have a large number of web contents, web assets they want to use, then this is a good service to keep in mind, in which case SSL certs can be requested from certificate manager, and we will renew the cert on behalf of the customer. And in here we have a cert that's being requested. To request cert is very simple. You just hit request and a cert will be granted to you. And once the certificate has been requested, then the customers can easily incorporate that into their load balancer. And that will give them the ability to eliminate the need to manage certs again and just do SSL offloading to the load balancer. Okay, so we have one that's not configured with the cert yet. So to get a cert inserted, you simply select the protocol for load balancer and then insert and install the cert that's been granted to you from ACM. Okay? So as simple as that, you have done SSL offloading to the application load balancer. Okay, now we have gone through the services that are funding the applications. Now let's take a step back and take a look at the visibility aspect of things. So Kinesis is a service that we leverage to ingest data that's centrally stored on an Amazon S3 bucket into the service on behalf of customers, so customers don't need to worry about the infrastructure needed to support Elasticsearch for index building. So we have various streams that are being delivered to Elasticsearch cluster, ranging from the CloudFront access logs, the CloudTrail, which monitors the API access to various AWS resources, the VPC flow logs, the application load balancer, as well as the web server logs that to Kinesis Firehose. So these streams are delivered to Elasticsearch. Let's get into Elasticsearch service itself. Now we are in the Elasticsearch console here. Take advantage of the index and do interactive searches using a visualization tool that could be coupled easily with the Kibana listed here. So these are the index that customers could do searches on and create immediate visualization of how their web application is being accessed globally. So let's do one real quick based on the destination IP. Chart that could be created within a few seconds. And then let's do another one for fun. If we select, for example, security groups that exist in the customer's environment, and we get to easy visualization of what the amount of traffic breakdown between security groups that's configured for the environment. Okay, and if you are a visualization guy like myself, then you could do a global map of how your web application is being accessed globally with a click of a button, as an example here. So this is a heat map of the web traffic that's hitting the application. So customers do have the ability to easily create searches interactively, say who is accessing my application over port 80 across the world, and whether those requests has been accepted, okay, or rejected. Okay, so immediate refresh. Let's say let's do 443 with encryption. Then that's a simple search away. Okay. And now let's do something else as well. Say who is logging into my AWS console? You could do that easily with a simple search. If you have teams only in the US East, and that's what you expect. But if you see something else, then you could respond immediately to it. Okay? And let's say SSH pattern to port 22, all can be done easily and dynamically by having a central location for the logs ingested into Elasticsearch service, coupled with Kibana for visualization. And with that, we just did a quick demo of a practical use case of migrating web-facing applications seamlessly into VMware Cloud and AWS Service, and then also seamlessly take advantage of the built-in native services to add layers of security protection for the customer's internet-facing application with end-to-end visibility. And with that, I'd like to pass control back to Andy for a Q&A along with Artie and the team.
Great, thanks, Wen. So now we would like to take an opportunity to answer any questions that you may have. So if you could please address your questions in the chat. We'll bring in Artie, who will read the questions and then provide an answer back to you. So if you do have questions of anything we presented on today, or any questions about VMware Cloud and AWS in particular, on the right-hand side of your screen, there's a section for questions and answers. Just enter your question there, and we'll have Artie come on and answer the questions. Artie, over to you.